Welcome to a lesson with Dr. Powell. Let's talk about this wedge notation a little bit. dx, wedge dy, what does this mean? Basically, this is kind of like an area operator. If I have a little dx and a little dy, then it tells me the area made from this dx and dy from a little square differentially. Now, what would happen if I put dx, wedge dx together? There would be no area. So this would be 0. Something else, if we were to reverse this, dy wedge dx, what does this mean? Order is really important for this operation. What this means that as I have these ordered, is y, or is dy located counterclockwise from x? So here's the dx, and here's the dy. And so as I've written it, so this is the way I'm viewing it. I'm viewing x and then counterclockwise motion to y. If I were to write down dy dx, that means I'm looking at this same bit of area, but the way I'm looking at it is that y is, so to move from dy to dx would be counterclockwise. So in other words, dy to dx, this motion is counterclockwise. Well, this would only happen and only be available if I were to turn this upside down and look at it from the other side. So think dx and dy and looking from the other side, and then I just rotate it over here. So on the other side, that's what I'd be viewing if I see a dy dx. Now, we say that we would like this area to be the negative of the other area. We want, if we're looking at area from one side versus the other side, we want the sign to be different. So we standardize that by saying that every time we switch order, we reverse the sign of area. So here, dx dy is in the proper order of counterclockwise orientation. But if I switch just once, then I'm in the opposite. And so the area I would interpret as being negative. Thanks for watching.